So I have coded the program counter in the Vivado software and in the Verilog language. So first we have to create a module with a name PC. That is the short form for the program counter. And then we take input clock, input reset. This is a short form for clock and reset, and then input via PC next. What is PC next? That is program counter address, the next address as it stores, and then output PC. Why we declare wire? Because it represents the physical connections, as the clock and the reset is given to the PC counter in the physical wire format. And this reg, why we write reg? Because the PC stores the the PC output stores some value in it. Now after that we write always at the rate postage clock or postage reset. Why we write this? If the clock is there, then it shows the clock value, or it shows the reset value. Then begin. Then afterwards we apply the condition. If the reset, the PC अगर reset होता है यहाँ पर clock नहीं होता है, if it is reset, then PC is less than equal to PC is less than equal to 32 dash D0. What is 32 dash D0? 32 is the bits. So it's a 32-bit architecture of the processor. So with required to write 32 and then comma. This is the syntax of writing this, and then D0. What is D? D is decimal. So we are writing this input in the form of the decimal number. And what is the input? That is 0. So in 32 bits we provide this 0 decimal number. We can also write in the binary, but for our convenience we write it in the decimal. Else the vivado tool automatically convert any number that you given in any form into the eventually into the binary. Then in the else part we write PC less than equal to PC next. That is the address of the next instruction. Then and this loop and the AND module. So this is our main code for the PC. Then we created the PC test bench with the PC test name. I will explain how you can create the test bench and the main source file in the Vivado. So in the same way we write this, but here if you observe that we write rag where we once write the wire for the clock and the reset. Why? Because when we test, we provide the values in the clock and reset manually in our code. So it will act it like storing a value, and the PC that is now acting like a physical wire. Then same way with the PC next, it will act like a reg for us. Now after this, we again mention the module of our main file, that is PC. Then we can create instance of it by any name which is not the keyword name. Then we make references of all the input and output here. Then we write this always hash 5 clock, that is similar to the clock. So why 5 hash is 5 nanosecond, and then initialize begin. Then we assign values for each input and output, so that clock is initially 0 and the reset is 1 and the PC next is also 0. Now afterwards, we, because these are the rags, we assign only in those values that are rag, defined as rag, right? We cannot assign in the wire, right? Now for the 10 nanosecond, the we assign the reset as 0 and PC next. Now the PC next we given manually because of this act as a wire. So for checking, we given manually without initializing. So 32 days old. Since we are in the process of making the 32-bit processor, and in that diagram, the PC is connected with the adder, and that adder we get the PC plus 4. So in addition of 4 is there. So for our convenience, we add the 4 in the decimal, and after every 10 nanoseconds we check for this thing, it will execute it in the proper manner or not. So according to that, we give the numbers to the next PC next. So after addition of 4 in every increment or every clock cycle, not clock cycle, every clock signal, right? Then finish and add module in the same manner. Now I have to show you how to create the design sources and the simulation sources. So you can click here, and for design sources you can select this, and for creating simulation you can select this. So if you want to create this, then next and create file. You can type any name here, any name, and then OK, and then finish. After finishing, you can give input here and whatever the name of the input here, and select the bus if you have to declare that, so you can easily do that. Then click on OK, so you can create the sources in this way. Right. Now for after creating this, a file of main source comes into this folder, and for the simulation of test bench, the file is created in the simulation sources. So now after writing the code, we can run our simulation. So run the behavioral simulations. I'm giving and describing this whole according to my knowledge of the Verilog language and using this vivado tool. Since I'm also beginner, so I may mistake in some terms, and maybe I also misinterpreted some meanings of the code. So forgive me that and forget that. Now let's see the simulation. Here is the objects that we created with the name and value and the data. Now this 000C that you see in the end is, this number is in the hexadecimal, so for C that is 12. So you can see here easily that our simulation runs properly. See, first 0, then 4, then 6, 8, and then 12. The 12 is represented in the hexadecimal, so it's 0. Right. And after the simulation happens, what we can do is RTL analysis. So for RTL analysis, open the elaborated design. Okay. It will take a little time and making. Wait for some time. So this is a diagram for the PC, that is program counter, right? And you can check the diagram. I'm not from the EC branch, so I cannot tell you whether it's correct or not. I can just verify it using the ChatGPT for my convenience. Now, after this happens, our code for the program counter is done here, and for the next part of the next module of 32-bit processor, please go and watch the second part.